I'm Richard Potter from the Human-Computer Interaction Laboratory at the University of Maryland. I'd like to show you how graphical macros can let users customize their computer applications by implementing new features. Having the right feature at the right time can take a seemingly difficult task and make it almost effortless to do. In most situations, built-in features can be found in the application that fit the user's needs. For example, putting parentheses around all the negative numbers in this table would be laborious to do by hand, but it's trivial to do with a built-in feature of this spreadsheet application. When such powerful built-in features match the task at hand, it is as if magic has happened. It is no wonder that software companies have felt the pressure to include more and more features into their applications. But in many situations, an appropriate feature either does not exist or cannot be found. For example, what if the person wanted to do something just a bit novel, like print out their spreadsheet with all the negative numbers circled? Even the most full-featured applications cannot have enough features to cover the needs of every user. Adding more features leads to other problems. So many features can accumulate that it becomes difficult for a user to determine whether a feature exists or not. One solution is programming in the user interface. Programming in the user interface allows users to invent their own features that are matched precisely to the task at hand. Programming in the user interface works by letting users combine the built-in features of applications and thus create features that are specialized to their tasks. We have created a programming in the user interface system called Triggers. Like all programming in the user interface systems, Triggers allows users to invent new features by building on the application's existing features. In this case, we use Triggers to customize the spreadsheet's oval drawing tool such that it seeks out negative numbers and draws an oval around them. Triggers automates with graphical macros. Triggers simulates the actions of the user, much like keyboard macros that have been so effective in character-based user interfaces. Mouse and keyboard actions are performed as if the user did them. However, unlike previous keyboard macros, Triggers also scans the pixel representations on the Macintosh's display. This addition of pixel pattern matching to macros makes them more effective in graphical user interfaces, thus the name Graphical Macro. The main advantage of this graphical macro technique is that Triggers can work with any application on the Apple Macintosh. Another example is to draw the suspension cables of this bridge. The built-in features of this drawing application make most of the process go rather quickly. The duplicate feature makes it trivial to space the lines out evenly. However, the next step is to shorten the tops of the lines down to the top of the support cable. None of the built-in alignment features seem to do what we want. This is another specialized feature that can be created with Triggers. By using a user-created feature to automate this task, many tedious mouse drags are averted. Graphical macros can also be used with textual applications. Here the task is to add citation labels to each bibliography entry. Triggers also allows users to apply an action to all files in a folder. For example, here we are appending the word old to every file name. The graphical macro technique used by Triggers is a unique way to do programming in the user interface. Much like a human user doing a task, it relies only on simulating key presses and mouse actions, and the novel technique of reading pixels off the screen. However, the user sees the computer display, keyboard, and mouse very differently than graphical macros do. To the user, the computer screen shown here is more than a drawing program displaying lines and curves. The user can see real-world objects, like the bridge with its roadway and suspension cables. Graphical macros have access to the same view, but instead of a bridge, graphical macros see this computer screen as collections of black and white pixels. Still, graphical macros can perform useful tasks, much like fax machines can send meaningful documents by sending only low-level pixel information. The key to making graphical macros perform useful tasks is a user interface that empowers the user to relate these low-level patterns of pixels to their higher-level goals. Now we will show how to create the graphical macro that shortens the lines on the bridge. First, we put triggers in a special mode for creating graphical macros. The graphical macro must find the top of a line to shorten. Because the pixels are always visible to the user, and because the user is practiced at pointing to parts of the display with the mouse, the user can use direct manipulation to directly point at the pattern of interest. Another important user interface technique is programming by demonstration, the creation of programs through the use of specific examples. For graphical macros, these specific examples are the contents of actual computer screens. Without context, the selected pattern is simply a number of black and white dots. But by using programming by demonstration, the user can see the pattern's meaning in the context of the computer's graphical user interface. Part of what gives a pattern meaning is its location. Thus, triggers provides a mechanism to specify where to search for a pattern. Here we are dragging out a search area to indicate where we expect tops of lines to occur. Next, we must specify a pattern that identifies where the line intersects the support cable. Because each line intersects at a different angle, we must be careful in choosing a pattern that is common to all intersections. One pattern that will work is a single black pixel. Triggers provides a zoom feature that will allow us to select this pattern with confidence. With such a small pattern, it is especially important to specify where the pattern is meaningful. In this case, the pixel identifies the intersection point if it occurs adjacent to the line we want to shorten. We indicate this by positioning the search area adjacent to the line. Next, we indicate that the search area is located a certain delta distance from the location of the previously found pixel pattern. Now that the top of the line and the intersection point have been found, we can demonstrate mouse actions relative to these locations that will shorten the line. Mouse downs will be relative to the top of the line, and mouse ups will be relative to the pixel pattern found next to the intersection point. Now we record the actions in a manner familiar to anybody who uses this drawing program. First, we click the line to select it, and then we perform a mouse drag to shorten the line. Triggers provides animated feedback that makes it easy to step through and verify the correctness of a graphical macro. Here we see a successful search for the top of a line. Next, a successful search down the edge of the line for the point of intersection is animated. The location of the mouse click is foreshadowed. And finally, the mouse down, drag, and mouse up that shortens the line is foreshadowed. Any of these visual representations can be edited on the fly if minor corrections are needed. Once the user has confidence in the graphical macro, it can be run without feedback to quickly perform the task. Graphical macros have some limitations. Only certain types of information can be found with the screen pixels. Working through an application's user interface can slow down a customization. Graphical macros must share the devices with the user, thus making it difficult to automate tasks in the background. And graphical macros can be sensitive to low-level details. However, in many situations, the unique advantages of graphical macros make up for these limitations. For software developers, graphical macros provide a low-cost way to include significant customizability in their applications. For users, graphical macros offer the opportunity to significantly customize any application. Also, users do not have to have any knowledge of the application's underlying data structures. In an ideal world, one might imagine that applications will eventually include all the features that users could need. But in practice, users' needs are so diverse that some of these needs will not be met. Systems that include programming in the user interface empower users to create some of these missing features for themselves.